Good evening, Honors Algebra. This is Mr. Lawrence with your flipped lesson for the weekend of December 9th, 10th, and 11th. And guys, this is going to be such a simple lesson. Do me a favor, don't make it hard. Don't make it hard. Today we're going to learn how to graph. Oh no, I'm not in writing mode. Oh, graph absolute value. No, Mr. Lawrence, we're not graphing absolute values today. We're actually just graphing inequalities. We're going to graph inequalities. It's super duper simple. One thing you want to keep in mind is y equals mx plus b, slope y-intercept form of an equation. We're not actually going to graph equations that look like that. We're going to graph equations that look like this. Or perhaps they will look like this. Or if we feel really daring and exciting, they might look like this. Oh my goodness. Or for those of you that are extreme mental giants, they might look like this. Wow, this will be crazy. Of course, we can use the standard form of these inequalities as well, or point slope form, or whatever the case may be. So let's look at an example. Let's look at an example. Let me get a graph up here. There's my graph. Now I need an equation, an inequality actually. Look at that. There's my equation. It's almost like it's magic. Almost. All right, I'm going to pretend that this equation says equals, and I'm going to graph it the same exact way that I would do y equals 2x minus 3. You should be experts at this. You need to go back and review, perhaps watch a video, perhaps look it up in the book if you don't know how to do this. I know this is my y-intercept. I am expecting you to know how to do this, so I'm not going to explain it. This is my slope as a fraction to be 2 over 1. So I go to the y-axis and I go down 1, 2, 3. And then I rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. If I come to the other side, I go down 2 and back 1. Down 2, back 1. Some of you are going, wait, shouldn't there be a v? No, there's no v in this. Do you see an absolute value? Do you see absolute value bars? Nope, you don't. Look, they're gone. Ha ha! So there is no absolute value bars. So we don't bend the line up. We don't get a v shape. We get a straight line, which is redundant because all lines are straight. Okay, hold on. Let me get rid of this. And let me get a nice little line here. And I will draw my line. Ooh, such a pretty line. Yes, yes, a very attractive line, I must say. Okay, let me make him red. And there we go. There's my line. Now, the only problem is this doesn't say equals to. It says less than or equal to. That means that there are going to be more points involved in my answer than just the ones on the line. Just like if I had x was greater than 5, greater than or equal to 5, I would draw a little number line. I'd put a 5 there. I'd include 5 in my answer, and then I would shade to where all the solutions are, all the numbers greater than 5, right? It's very similar in a problem like this. I'm going to have many, many, many more points that are part of the solution than just the ones on the line. Where do those points lie? Well, you know what I'm going to do? I'm going to do some shading. Where am I going to shade? I'm going to pick a test point. I love to pick the origin as my test point. I love to pick the origin as my test point. I'm going to plug the origin into this equation. If I get a true statement, I will shade where my test point is. If I get a false statement, I will shade the other side of the line. Let me say that again. I'm going to pick a point that is not on the line. I like to pick the origin because 0, 0 makes the math easy. By the way, I can't pick the origin. Tell me. I can't pick the origin if the line, come on, tell me. I can't pick the origin if the line goes through the origin. All right, so I'm going to pick the origin. My line is not going through it. I'm going to plug in 0 for y, 0 for x, and see if I get a true statement. So 0 is less than or equal to 2 times 0 minus 3. Simplifying the right-hand side tells me that 0 is less than or equal to negative 3. How? 2 times 0 is 0. 0 minus 3, negative 3. Is this true? Is 0 less than negative 3? No way, Jose! I will not shade my test point. I will shade everything below. Ooh, I like the color. Ooh, hoo, hoo. Look at that. I'm such a beautiful colorer. There we go. And that's good enough shading. The points that are the solution to this inequality right here include all the points on the red line and all the points in the yellow region. That means if I pick a point, say 1, 2, 3, 4, 5, 1, 2, 3, 4, the point 5, 4. If I put 5 in for x and 4 in for y, I'll get a true statement. Watch. 4 is less than or equal to 2 times 5 minus 3. Well, 2 times 5 is 10. 10 minus 3 is 7. Is 4 less than or equal to 7? Yep, bingo, it works. If I picked a point here and plugged in the x value and the y value, I will get a true statement. That's what this yellow shaded region is telling me. On the contrary, if I pick any point over here, any point, like the origin, and I plug in the x value, x coordinate, and the y coordinate into the original inequality, I will get a false statement. This is actually pretty easy. You just got to remember to shade. All right, hold on one second. Where did my recorder go? Okay, now, you know how when we had like x is greater than 5? When we did our number line, the difference was that, 5 is not included in the solution. So therefore, sorry about that, there was a momentary interruption. But when we have x is greater than 5, we leave that circle open and we don't shade. Or we shade, but we don't shade in the 5, right? Well, when we have an equation that looks like this, say y is greater than, I don't know, negative 2, well, I just did 2, huh? Let me do negative 1/2 x plus 3, okay? I'm going to graph this one the same way, except something different is going to happen. So I find my y-intercept, which is 3. 1, 2, 3. My slope is negative 1/2, so I'll go down 1, right 2. Down 1, right 2. Down 1, right 2. Now, I've said this many times in class. I don't even realize this. Negative slopes go downhill to the right. Okay, positive slopes go uphill to the right. All right, so we're going to go up 1, back 2. Up 1, back 2. Up 1, back 2. All right. Now, before I go to draw my line, these points form the line, but they are not a part of the solution. I can prove it. This point here is the point, this point here is the point 0. Oops, I'm not in right mode. The point 0, 3. If I plug 0, 3 into the inequality, I will get a false statement. Watch. I'll put 3 for y. It's greater than negative 1/2 times 0 plus 3. If I simplify the right-hand side, I should get 3. Is 3 greater than 3? So you see these points here are not a part of the solution. They form the line which makes the barrier, but they don't give us a true statement. So to deal with that in a number line, we did the open circle, like exhibited right here. But on a graph like this, a linear graph, we don't do that. We use a broken line. So we do a dashed or broken line like that. Okay, that's just how we represent it. All right, so let me see here. Shoop, shoop, shoop. There we go. Now, because it's an inequality, I have to do some shading. I have to do some shading. I want to know where to shade. Well, I'm going to pick a test point. I love to pick the origin. Did I mention I love to pick the origin? The only time I can't pick the origin is when the line goes through the origin, right? So I'm going to pick the origin. So y is going to be 0 greater than negative 1/2 x, 1/2 times 0 plus 3. All right. I'm going to simplify. I'm going to get 0 is greater than 3. That is a false statement. Because it is a false statement, I will shade below my broken line. Had it been a true statement, I would have shaded above it. Okay? Oh no, Mr. Lawrence, you're shading wrong. Yes, I know, but watch this. Because of smartboard technology, zoop. Oh no! Spin! Spin, I say! All right, and then I'll fill in this gap here. Yes, I was making a small mistake. Before you yell at me or throw a TV brick at your computer monitor, you can see that that is the correct solution because the origin gave me a false test. So I didn't shade where the origin was. Let's do one where I shade where the origin is. Actually, it's not even going to be an origin one. It's going to be one where I can't use the origin. So I need a piece of graph paper. Paper. Ah, I'm in color mode. Let me get out of this. All right. Oh yes, I have to laugh or I will cry. Very good. Okay, there is my coordinate system. And let's say I have an equation like this one. Y is less than 3/4 x. Okay, I know the y-intercept is going to be at the origin. My slope is up 3, 1, 2, 3, right 1, 2, 3, 4. Up 1, 2, 3, 1, 2, 3, 4. And to go down 1, 2, 3, back 1, 2, 3, 4. And I can draw a nice pretty line here. Now, is my line going to be solid or broken? Which one should I choose? I notice that this does not say equals. That means I shall use the broken line. Yes. 1, 2, 3, 1, 2, 3, 4. So there's my broken line, and I shall make it so that it has an arrowhead on each side. Looks like it moved a little bit. Okay. Now, I have to decide where to shade. In this case, I cannot pick the origin. I'll pick another easy point to use. For example, I like to make x 0. Why? Because I'll do 3/4 times 0. So I'm going to pick the point, say, 0, -2. Right there. 0, -2. I'll plug in -2 for y. I'll plug in 0 for x. I'll simplify the right-hand side and get 2 is less than 0. -2 is less than 0. Is that a true statement? Ding, ding, ding. Why, yes, it is. Since that is a true statement, I will shade the side of the line that my test point is on. And there we go. Any point in that yellow region will yield a true statement if I plug it into that original inequality. Any point on the other side of the line will give me a false statement. And that is graphing inequalities. It really doesn't get much harder than that. Let's look at one that's not in slope y-intercept form. Oh, I'm doing it again. Go away, Mr. Yellow Ball. Okay, let's say we had an equation that looks like this. 2x minus 3y equals 6. Well, this is in standard form, so I'm probably going to either find both intercepts, graph it that way, or find one intercept in the slope. I'm going to quickly review that A, B, C. And remember that A must be positive. My A is positive, so I'm good. The x-intercept is found by doing C divided by A. The y-intercept is found by doing C divided by B. And the slope is found by doing negative A over B. All right, so I'll go ahead and find my intercepts. My x-intercept looks like it's going to be 3. 1, 2, 3. Okay, my y-intercept looks like it's going to be -2. 1, 2. Now, I could figure out my slope and see it's going to be -2 over -3, which simplifies to 2/3. Or I could just simply count slope from my two intercepts. Up 1, 2 over 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. I feel like I'm dancing. Cha-cha-cha. Down 2, back 3. Down 2, back 3. And there we go. Now, problem is I made that an equals. I need to make it a less than or equal to. Sorry about that. But the point is we do the same thing that we would if it were an equals or an equation. All right, I'm ready to graph. My line is, you can see I already chose a solid line. Down 2, back 1, 2, 3. And there we go. There's my solid line. It's an inequality. There needs to be shading. We get an arrowhead on him. All right. Can I use the origin as my test point? I sure can. Why can't I? Because the line does not go through the origin. All right. Let me get some room to work here. I shall plug 0 in for x, 0 in for y, and see if I get a true statement. The left-hand side will simplify to 0. 0 is less than or equal to 6. You bet your bootstraps. It sure is. Because it is, I will shade the side of the line that the test point is on. If I pick any point on the line or any point in the green shaded region, I shall get a true statement. And there you go. It's just that easy. Monday when you come in, we'll go ahead and practice graphing them. Okay, Monday night's lesson will be a review to help you get ready for Tuesday's test. All right, Mr. Lawrence, I don't think I have anything else to say. I'm going to sign off and say, hey, great weekend, everybody. We'll see you on Monday.